question involves adding electrical panels to an agricultural site with an existing 1200 amp single-phase service. Currently, the service feeds 4 200 amps panels, one in each building. The inquiry is whether a second 200 amps panel can be added to each building. Based on the information provided, adding a second 200 amps panel in each building under the current configuration is not recommended. Here's why. The existing 1200 amps single-phase service provides a maximum of 1200 amps of current to the entire site. Each of the 4 existing 200 amps panels draws up to 200 amps, resulting in a total of 800 amps of current being used by the existing setup. Adding a second 200 amps panel in each building would increase the total current demand. Let's calculate the new demand. 4 new panels, each drawing up to 200 amps, would add another 800 amps to the load. The total current demand would then be the existing 800 amps plus the additional 800 amps, equaling 1600 amps. This 1600 amps demand would exceed the 1200 amps capacity of the existing service. Exceeding the service capacity creates an overload condition. An overloaded electrical system can lead to several problems. Firstly, it can damage electrical equipment due to excessive heat. Secondly, it increases the risk of electrical fires. Thirdly, it can cause voltage drops, affecting the performance of electrical devices. To safely add additional electrical capacity, there are a couple of options to consider. The first option is to upgrade the existing service to a higher amperage. This would involve replacing the existing service entrance equipment, including the main breaker, wiring, and possibly the meter. A licensed electrician would need to perform a load calculation to determine the appropriate size of the new service. Secondly, it can be considered to install sub-panels within the existing 200 amps panels. This approach involves distributing the additional load more efficiently within the existing capacity of each 200 amps panel. It requires careful load management and may not be suitable for all applications. Before making any changes, it's essential to consult with a qualified electrician. An electrician can assess the existing electrical system, perform a load calculation, and recommend the best course of action to meet the increased demand safely and in compliance with local electrical codes. The National Electrical Code, or NEC, provides guidelines for electrical installations, including service sizing, panel board requirements, and conductor ampacity. Following the NEC ensures a safe and reliable electrical system. When considering an upgrade, several factors must be taken into account. Firstly, conduct a thorough load calculation. This calculation determines the total electrical demand of all the equipment and devices that will be connected to the system. It's important to consider both the continuous and non-continuous loads. Continuous loads are those that operate for 3 hours or more at a time, while non-continuous loads are those that operate for shorter periods. The NEC requires that continuous loads be multiplied by 125% when calculating the total load. Secondly, select the appropriate service size. Based on the load calculation, the service size must be selected to meet the total demand. The service size is typically expressed in amps, such as 100 amps, 200 amps, or 400 amps. It's important to choose a service size that is large enough to handle the current load and any future expansion. Thirdly, choose the correct conductors. The conductors that connect the service to the panel board must be sized to carry the full load current. The NEC provides tables that specify the ampacity of different conductor sizes based on their insulation type and installation method. It's important to use conductors that are properly sized to prevent overheating and voltage drop. Fourthly, use the appropriate overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. These devices must be sized to match the ampacity of the conductors they protect. The NEC provides guidelines for selecting the appropriate overcurrent protection for different types of circuits. Fifthly, ensure proper grounding. Grounding is essential for electrical safety. It provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. The NEC requires that all electrical systems be properly grounded. This includes grounding the service entrance equipment, panel boards, and all metal enclosures. Sixthly, comply with local codes and regulations. Electrical installations are subject to local codes and regulations. These codes may vary depending on the location. It's important to be familiar with the local codes and regulations and to ensure that all electrical work complies with these requirements. Seventhly, hire a qualified electrician. Electrical work can be dangerous. It's important to hire a qualified electrician to perform any electrical work. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in compliance with all applicable codes and regulations. In summary, adding a second 200 amps panel to each building without upgrading the existing 1200 amps service is not recommended due to exceeding the service capacity. It's crucial to consider upgrading the service or installing sub-panels within the existing panels, along with consulting with a qualified electrician to ensure safety and compliance with electrical codes. Remember, a thorough load calculation, proper service sizing, appropriate conductor selection, overcurrent protection, grounding, and compliance with local codes are essential for a safe and reliable electrical system. If the existing panels are close to full, consider a subpanel. A subpanel is an additional panel that is fed from the main panel. This can be a good option if the main panel does not have enough space for additional circuits. Firstly, consider the location. Subpanels can be located anywhere in the building, but they are typically located close to the area where the additional circuits are needed. This minimizes the length of the branch circuits and reduces voltage drop. Secondly, consider the size. The size of the subpanel should be based on the number of circuits that will be installed in it. It's important to choose a subpanel that is large enough to accommodate the current load and any future expansion. Thirdly, consider the main breaker. The subpanel must be protected by a main breaker. The size of the main breaker should be based on the ampacity of the feeder conductors that supply the subpanel. The NEC provides guidelines for selecting the appropriate main breaker size. Fourthly, consider the branch circuits. The branch circuits that originate from the subpanel must be properly sized and protected. The NEC provides guidelines for selecting the appropriate conductor size and overcurrent protection for different types of circuits. Fifthly, consider the grounding. The subpanel must be properly grounded. The grounding system should be connected to the main panel's grounding system. The NEC provides guidelines for grounding subpanels. When installing a subpanel, it's important to follow all applicable codes and regulations. It's also important to hire a qualified electrician to perform the work. A qualified electrician has the knowledge, skills, and experience to install a subpanel safely and in compliance with all applicable codes and regulations. The ampacity of conductors is a critical factor in electrical installations. Ampacity refers to the current carrying capacity of a conductor expressed in amps. The NEC provides tables that specify the ampacity of different conductor sizes based on their insulation type, temperature rating, and installation method. Factors affecting ampacity include conductor size, insulation type, temperature rating, installation method, and ambient temperature. Firstly, conductor size. Larger conductors have a higher ampacity than smaller conductors. This is because larger conductors have a lower resistance, which reduces heat generation. Secondly, insulation type. Different insulation types have different temperature ratings. Conductors with higher temperature ratings can carry more current than conductors with lower temperature ratings. Thirdly, temperature rating. The temperature rating of a conductor is the maximum temperature that the conductor can withstand without degrading its insulation. The NEC specifies the temperature ratings for different types of conductors. Fourthly, installation method. The way a conductor is installed can affect its ampacity. Conductors that are installed in free air have a higher ampacity than conductors that are installed in conduit. This is because conductors in free air can dissipate heat more easily. Fifthly, ambient temperature. The ambient temperature is the temperature of the surrounding air. The ampacity of a conductor decreases as the ambient temperature increases. The NEC provides correction factors for adjusting the ampacity of conductors based on the ambient temperature. When selecting conductors for an electrical installation, it's important to choose conductors that have an ampacity that is sufficient to carry the load current. It's also important to consider the derating factors for ambient temperature and the number of conductors in a raceway. The NEC provides guidelines for derating conductors. The NEC Table 310.15 specifies the allowable ampacities of insulated conductors rated up to and including 2000 volts. This table is used to determine the appropriate conductor size for a given load. The table takes into account the conductor material, insulation type, and temperature rating. In addition to Table 310.15, the NEC also provides derating factors for ambient temperature and the number of conductors in a raceway. These derating factors must be applied to the allowable ampacities in Table 310.15 to determine the adjusted ampacity of the conductor. It's important to consult the NEC for specific requirements regarding conductor ampacity. Failure to select conductors with sufficient ampacity can lead to overheating, insulation failure, and potentially electrical fires. Therefore, always prioritize safety and compliance when working with electrical systems. Furthermore, carefully consider the existing electrical infrastructure's capabilities before adding new loads. An undersized service can create unsafe conditions and negatively impact the performance of connected equipment. Consulting a qualified electrician is always the best approach to ensure a safe and compliant electrical installation. They can assess the situation, perform necessary calculations, and recommend the most appropriate solutions. The electrician will also be able to ensure that all work is performed in accordance with the NEC and local codes. Furthermore, it is important to note that electrical codes and regulations are subject to change. Therefore, it is important to stay up to date on the latest requirements. This can be done by attending continuing education courses or by subscribing to industry publications. In conclusion, adding electrical panels requires careful planning and consideration. It is crucial to assess the existing electrical system's capacity, perform load calculations, select appropriate components, and comply with all applicable codes and regulations. By following these steps, you can ensure a safe and reliable electrical installation.